So one important terminology that we keep, encountering in our rotational motion study and torque study is the rotational equilibrium. So the term equilibrium is pretty commonly used in a lot of different topics, but in the topic of torque, in the field of torque, how we actually, define equilibrium or rotational equilibrium is that sum of torques should be equal to zero. Should be equal to zero, right? So for a system, the sum of torque should be equal to zero, and torque, since it is a quantity, it is a physical quantity which is dependent or associated with directions. It is affected by directions. We actually talk about the counterclockwise torque and clockwise torque. So it is something that actually has direction. So we can conclude that torque is a vector quantity. And for a system, the overall sum of the torques should be equal to zero for it, so that it can be called to be in rotational equilibrium, right? So this is, analogous to the concept of, the principle of moments that we discussed, that for a body needs, that needs to be balanced, the sum of the counterclockwise moments should be equal to the sum of the clockwise moments, which is, this is a similar thing to that, the rotational equilibrium. We can just, the balance thing in that principle of moments, statement, when we said that the thing, for a system, needs to be balanced. By balance, we actually meant for the thing to be in rotational equilibrium. Whenever we say equilibrium, we are actually talking about the thing to be in a balanced state. So the sum of the torque should be equal to zero for anything to be in rotational equilibrium. For example, there's a seesaw, which I can, preferably draw in another color. So there's a seesaw, and for example, there are some objects here and a very giant object here and very small objects here. They all are actually adding to some torque, right? In that seesaw. These objects on the left side of the seesaw are actually adding to the counterclockwise torque, and these objects on the right are actually adding to the clockwise torque. But if the overall sum of all the torques, if you just give the counterclockwise torque a negative sign, and the clockwise torque the positive sign, then add them together and you get a zero. If the sum of the torques is equal to zero, then this whole system can be called to be in rotational equilibrium. So this is pretty similar to the concept of principle of moments for a balanced system that we learned in the previous video.